Okay, thought I might just give you these general solutions to trig equations. Might just do a little video for you because I know some of you have got it and some of you will need to watch this a few times. Um, so general solutions of trig equations. The first one, probably the one probably that you is the easiest to get your head around is this one here. Good old cos is probably the easiest. So cos of x equals a, and of course a has to be between -1 and 1, because if you take the cos of any angle, it comes out between -1 and 1. We understand that from the from the unit circle. So you got a unit circle. Better try and draw the axis straight, I suppose. Try that again. To make that a bit thicker and just bring it up a little bit more, maybe something like this, Yeah. Okay, so cos of x equals a. So we're coming out at an angle x. Should have done that in pen. Yeah, let me go back, try that again. So we're coming out at an angle x, and its cos is a. Yeah, so sure. So this angle here is inverse cos of a. Yeah, but you can go around again, and you can go around again, and go around again, and that's so. So 2n pi, any integer multiple of 2 pi lands you back here, and if you take the cos of that angle, you get a. Hey, but also these ones down here. So like that's the negative of the inverse cos of a down here, and therefore if you take any pi, any n multiple of 2 pi, keeps landing you here. So that's also another solution. So therefore, when we see this, we say that in general, then, if cos x equals a, x is any even multiple of pi, and you can either go forward or you can come back inverse cos of a. Yeah. With that, you should be saying n is an element of z. Yeah, good. Okay, so the next one, we'll leave sine to last because it's a bit trickier. So tan of x equals a. Well, we know in this case that take a is an element of the reals, because when you take the tangent. So we'll draw that. Well, I'll draw that again. We'll draw another unit circle. I need a little bit more space this time. Might make the unit circle a little bit smaller. Might be too small. Try that again. Better not make it too small. Okay, not that easy to draw circles with this, but anyhow. Let's draw the axes. Try that again. Hold the shift key down first. That's better. Now we draw the tangent line. Might change colours for the tangent line. Didn't change colours, but anyhow, that'll do. Now, so that cos of x equals a, well, just to show that tan can run up to here, that's all right. Okay, so the cos of x equals a. Yeah, so this angle in here is the inverse tan of a. Yeah, because if you take the tan of this angle, you get a. But also, if you take the tan of this angle around here, which is inverse tan of a plus pi, well, plus any multiple of pi brings you around here. Then add on pi takes you back to where you start again. So we can say, well, x, the angle that such that you take its tan, you get a, is inverse tan of a, but you go around pi, takes you to the opposite side of the circle, and you still, when you take the tan of that angle, you get a, and then if you add another increment, another multiple of pi, takes you back to your first quadrant again. So don't forget, we've got to say n element of z. Okay, so if I can scroll down a little bit. Now the tricky one. What did I do there? Right. Sine of x equals a. Okay, better hurry up. Draw myself a nice unit circle. Better get me axes. Go through like this. Not bad. Put an angle A. Oh, that didn't go straight. Got to hold the shift key down first. Yeah, that's better. That's an angle X. Try that again, I'm not on the pen, sorry. That's an angle X. And if you take its sine, read across the y-axis, you get A. Yeah. So this angle here is the inverse sine of A. Because when we do this, we understand, whenever that A has to be between -1 and 1, because you take a sine of any angle, you're going to get out between -1 and 1. Now, of course, to land back here, as long as any angle when you land here and you take its sine, you're going to get A. So we can add on any even, so 2n pi, any even multiple of pi. The way we do that, we say 2n pi, make sure n's an element of the set of integers. But also over here, because if you land over here, if you get this angle over here, so come right around to here, come right around to here, and you take its sine, you're going to get A. So this is when you land over here, so pi. So pi. Well, really, and then come back, inverse sine of A, lands you right there. Well, actually, any pi, 3 pi, 5 pi, any odd multiple of pi, so 2n plus 1 pi. And of course, n has to be an element of z. So that's why sine is a little bit tricky. You sort of got to write it. The general solution is two different sets, I suppose. There is a clever way of writing it as one. Now, how does it go? Yeah, you say x equals inverse sine of a plus -1 to the power of n. Don't forget n's going to be come from the set of integers. So when it's odd, this becomes a negative. When it's even, so I've got that in the wrong way. Yeah, that's not what I want. So what I'll say is n pi plus -1 to the power n inverse sine of a. Hey, that works. N's an element of z, but I'll write it again here. I better get me rubber, because I'll be out this other muck. Get rid of that. Yeah. Come in and make it all look good. Okay. And then you can say x equals that. So what that does is, because when it's an even number, this ends up being a plus. So when we're even number, we go forward. We're right around there in the positive x axis, and we go forward inverse. So anti-clockwise inverse sine of a. And when this is an odd, when n's an odd number, this will be minus, and we'll be in our second quadrant, and picking up the set of solutions that's in the second quadrant. So that's trig general solutions for you. Hope that was helpful, and see you in class tomorrow.